In this video, we'll cover the problem song shuffling. Here, we want to create a function that plays songs in shuffled order. Specifically, we have to implement two methods. Or actually, this should be a class. We want to create a class. Now, the two methods are add song and play song. Add song takes in a song and just adds it to our current list of songs in our playlist. Play song randomly selects a song that has not been played and prints it to the console. And a song is represented by a string for the title, so for example, hello. Based on this presentation of the questions, it's not really sufficient to fully understand what's going on. So you'd want to ask some follow-up questions. And so we've written out some examples of what you should probably be asking along with answers here. So one question would be, what should I do when I've played all of the songs? And the answer is you should start over as if no songs had been played. Then there's also, what should I do if a song is added in the middle of us playing songs? For example, let's say we have 5 songs, we play 2 of them, and then somebody adds a new song. Well, in that case, we just want to add it to the pool of songs that can be played until we play it. Lastly, the question would be, what should I do if the user tries to play a song when 0 songs have been added? And in that case, you should print an error message and do nothing else. Note, we also have a follow-up question that the interviewer might provide after you complete the main question. That's at the bottom of this file. But for now, we're going to focus on the main question, and we'll talk about the follow-up later on. Okay, and one last thing to point out before we start talking about how to solve this question. We are not providing inputs of songs, but we are actually, we're not providing inputs of strings for our songs. We're actually using a song class because that is a better design practice. You can imagine that with songs, yes, for now we only want to store titles, but we probably, in a real-world setting, would want to store artist, genre, the album it's on, tons of other data, and it would be hard to do that if our code assumed that songs were just strings. So we are designing our code in an extendable way by using this song class. Okay, so conceptually, we have to have our add song function method and our play song method. It makes sense that we have a list of songs, so we probably want to use an array. So maybe when we just add song, we want to push onto some array. That could make sense. Then the question would be, how do we play a song randomly? Well, the very first time, we could literally just do a math.random over the entire array and pick an index and then use that song. However, the second time, we want to do the same thing, but we need to exclude the song that we played for the first time. So the way we're going to do this is we're going to chunk our arrays. So for example, here, we're going to say these are the songs we've already played, and these are the songs that we have not played. And to have this divider, we're going to have this pointer here, which we call the start index of unused songs. So from this pointer onwards, all of the songs are unused or unplayed. We have not used the song yet. Maybe unplayed would be better, but it's okay. So, yes, that is how we make the distinction. Then the question becomes, all right, how are we kind of moving songs here as we go? Luckily, I have this laid out so we can see it nicely. So we start with this array. Right, obviously our start index of unused songs is here because we haven't played any songs. When we play a song, imagine that it randomly selected 4. So we played 4. What we want to do is put 4 in the beginning of the array. So we will swap the position of song 1 and song 4 to get this array. And then we have to move our pointer upwards by 1 because remember it's the start index of unused songs, but if we use this song, then this is inaccurate, so we move it here. Once those updates are done, we can return song 4, and we're done for our current iteration. Next time, say that song 5 is what gets selected. We're going to swap song 2 and song 5. So song 5 is here, song 2 is here. Then we increment our pointer, and now we can return song 5. And conceptually, this is what the solution is going to do. So we store an array, and we store a pointer that's the start of our unused songs. Whenever we want to play a song, we move the song that we play, that we randomly select, to wherever our current start index of unused songs pointer is, and then we just increment our pointer. Okay, let's go ahead and see this in action. So we need to name our class shuffle. We need the add song and the play song methods as well. I lost where we are. Okay, add song play song. And then we also need our constructor so that we can create some state, because obviously we need this array to persist in between invocations of play song. So we'll have our songs, which is going to be an array, and then we'll have a start index of unused songs, which is going to be 0 initially because everything in our array is valid. Okay, like we said before, the let's see. Yeah, okay. We can just push onto our songs array whenever we want to add a song. So we could just say new song here, and it's just going to be push the entire new song. Remember, this is not a string, but it's actually an instance of the song class that contains a title property. Okay, now we have the play song function, which is where things start to get interesting. So here, what do we want to do? Well, first of all, we should make sure that we actually have some songs. So we can say if this.songs.length equals 0, we want to do something. I already forgot what we're supposed to do. Print an error message and do nothing else. Okay, so we will do that. We'll do console.error. We will say error, you have not, or no songs have been added to the playlist. And then we can return so that we don't do anything else. Okay, now that we know that we have some songs, but maybe we have played all of the songs. So there's also that case. Let us see here. Actually, now that I think about it, if we're handling all this logic, like that's probably a lot to be doing in this function. Yes, so I think we should not do that. What we will do is we'll do this. We'll do we'll have some function called get random unplayed song here, and it'll be a method on this class, and we'll say song to play is going to equal this. Then what we can do is we'll have this function return null in the case that we want to exit early, and then we'll do what we said before, which is we're going to console.error, and we're going to say error, no songs have been added to the playlist, and then we return. Otherwise, we're just going to print out song to play dot title. Remember, because these are all going to be song objects, like instances of the song class, we have to do this dot title right here. Okay, this way we've separated out our logic a bit, and we can have this function that's going to do a lot of the work. So the very first thing is the check from before, which is going to be if there are no songs, we're going to return null. That's how we've defined this right here. Now the other case is, what if we already have played every single one of our songs? Well, how would we know that? Well, we'd know that if the start index of unused songs gets past here, right? If the start index is right here, that's like, okay, song 2 is the only one left. But if it gets past here, nothing is left. So we can say if this index right here, the start index, is greater than or equal to, let's see, the song's length, like this songs.length, that means we're past here. Then we want to kind of reset. How do we reset? Well, that's actually pretty easy here. Well, first of all, to clarify, the reason I'm saying we should reset is because of this right here. We asked, what should we do when all songs have been played? And the interviewer told us we should just start over as if no songs have been played. So in that case, all we really need to do is just mark everything as an unused song. And the way we do that is we just move our pointer to 0. So what we can do here is say, we can call it maybe reset shuffle. We can just say, in this case, reset shuffle here. And what we'll do is we'll write a function, reset shuffle. This will be a simple function. It's actually just going to say, set this guy to 0. And what we can do is we can call the function here, this.reset shuffle. Okay, so now we know that when we're out of bounds in our array, we're going to reset the shuffle. Okay, at this point we can assume that we have songs, and we have at least one unused song. Then we need to get a random song. So we know that our range looks something like this. It would be this to this. And so this is a little bit of mathematical notation. This just means this number is inclusive, this number is exclusive because of the parentheses versus the square bracket. So we are saying we can start at this number and we can do anything that is smaller than this number. What we'll do is we'll say song index to play is going to be, and we'll have a function get random integer, and it'll take in the range, just like this. So we'll pass in here. And the standard with these kinds of functions is you write it so that the first one is inclusive, the second one is exclusive. And we'll write this function in a moment. Actually, you know what? Let's write this function right now. Note, I'm not writing it on the class because it's not unique to this shuffle situation. We can write it generically so that if someone else wanted to use this in the same code base that we're working in, then they simply could. They don't need to think about the shuffle class. This is nice, generic, and reusable. Okay, now how do we do this? I believe it looks like this. Math.floor of math.random times, and then the size of the range. I'll store that in a variable. So we'll say range size is going to be end of range minus start of range. And then here we'll do times range size. So what this does is math.random gives us something from 0, inclusive, all the way up to 1, exclusive. We multiply that by the range size. So if it was 10, then we get 0 up through just below 10. And then when we floor it, it goes down. It chops off all of the decimal places. So basically we get 0 through 9 if the range size was 10. However, we actually need to care about the start of the range because we might want to shift everything. Like what if we had 5, 10? Then our range size is 5. So we're going to get between 0 and 1. We multiply by 5. Then we have between 0 and 4. But really what we wanted was between, 5 and 10, right? So we should shift all of those. You know what? Actually, let me concretely write this out. So if we call this with get random integer 5, 10, then range size would be 5. Then here we would get math.random 0 and 1 times the range size of 5. So we get 0 and 4.9999. We floor it, so we get 0, 1, 2, 3, or 4. But what we want is we want 5, 6, 7, 8, or 9. Remember the 10 is exclusive. So what we can do is just shift these all to the right by 5, which is actually the start of range. So what we'll do is we'll do start of range plus all of this business here. Yeah, you can see this function is a little bit tricky and you have to think about it carefully, which is why it's nice to write this reusably so that no one else has to think about this in the future. Okay, great. Now we have the song index we want to play like we've decided here, song 4. Now remember there were 2 steps we did. We swapped the index we want to play with whatever we're currently at for our start index of unused songs. And then we just moved our pointer forwards by 1. So let's do that. I'm going to write a function, this dot swap songs. It'll take in the 2 indices. So we're going to swap wherever our start index of unused songs is, and then we're going to swap that with our song index to play. So let's write this function, swap songs. We could write this one generically maybe and take in an array and then 2 things to swap. Maybe that's actually better. Maybe not that. Maybe we want something that specifically handles how we swap songs. Yeah, I guess there could be other data that we need to update when we swap songs. So it's probably is better to keep this separate. But that's up to personal preference. You could certainly argue that it is better to do it the other way. In our swap songs, we'll just take in 2 indices I and j. So first of all, we have to store the value that's in the I before we overwrite it. Then we can say, all right, songs at I is going to equal songs at j. And then songs at j equals, remember if we did songs at I here, then we would just grab songs at j because we just overwrote it. That's why this was supposed to be I. This is why we have to store the temp variable and use that here. Yeah, okay. So now we've swapped our songs. The last thing we want to do is increment this guy here because, let's see our example. Yeah, so we have 1 and 4, we swap them, so we get this array here, but we want to say, all right, this is now a used song, so we should only consider these to be our unused songs. We increment our pointer by 1. So we'll say plus equals 1 here. And lastly, we can return this dot songs at our song index. Or maybe this should be song to play index. Index of song to play? Yeah, index of song to play. I like that better. Okay. By the way, if you didn't know, if you have a variable in VS Code, you highlight it and then press Command D, you can highlight other instances of it and just change them all at once, which is pretty nice. Okay. So now we have our get random unplayed song. It should do the swapping that we want. It should return the song after we swap and increment our index. It should also be able to handle the case where we have run out of songs to play, and it should reset us to the beginning. Okay, I believe that is all that we need to do for this function. So let's go ahead and test it out. The tests, I'm not super happy with the way I wrote them. You kind of have to do some manual checking of how it's working. Okay, so it's definitely not working. The way this works here is that the first test, we are adding songs, song 1, song 2, song 3, and then we're just playing 3 songs. So it should be, 3 different songs is what we should be getting here, but we're not getting that for some reason. Why is that the case? So, let's see here. Okay. Interesting. Okay, so we get random unplayed song. We're gonna say, all right, check if the length is 0, check if we're out of bounds. That doesn't really matter. Get the index of the song to play, so that's a random integer in this range. Swap the start with that index. That looks right. And then bump forward. Okay. Looks like this is the problem. I believe. Okay, hold on. So here we're swapping the 2 values. Oh, okay. Yes. So we're index of song to play now points to a different song than it pointed to here because we're swapping values. So what we need to do is we need to store song to play, which is this dot songs index to play. So before we do any index manipulation, we copy all right, this is the song we want to play, and in the end we should return that. Because this manipulation here is changing the actual song that this random index is pointing to, and we don't want that. Let's see if that changes anything. Yeah, okay. Now it looks like we're getting our 3 different indices. So what I was saying earlier is these tests, they're not that self-explanatory the way I've written them. The first test, you should be getting the numbers 3, 2, and 1 in any order. It'll change too if you rerun it. I don't even know if that was different. Here, this is different. I was hoping to use a seeded random numbers generator so that the tests could be more precise and reproducible, but JavaScript doesn't have one built in, so you'd have to install one via npm, and that just seemed like more of a hassle for anyone trying to do this. Okay, for test case 2, it should be printing the first 3 should be 1, 3, or 1, 2, and 3 in any order, and then the second 3 should be 1, 2, and 3 in any order. So we'll see if we run it a few more times, do we consistently get those results? Let's see, 1, 2, 3, that looks good. Looks good. Yeah, okay, it looks like we're doing fine here. And so this is just showing the case where we run out. So I can show you, we add 3 songs, we play 3 times, then we play again. And the expected behavior is kind of pretend as if we had played nothing, and you start over. Okay, test 3, we add nothing to the playlist, and then we see if we get undefined. That's true, that's what we want. And lastly, we have test 4, where we add 3 songs, we play 2 of them, then we add song 4, and then we play 2 of them. So the key is that song 4 should be one of the last 2 songs always. So here it looks like it is. Here, one of the last 2, one of the last 2, one of the last 2. Yeah, and other than that, obviously it should be 1, 2, and 3 in any order. But looks like we're passing there. Okay, so I believe our code is passing and does what is desired for the core question. Now we can have a chance to talk about the follow-up. The follow-up says, imagine that we're given the user's favorite genre, and when songs are added, we also have access to their genre. When shuffling, we want to give a higher weight to songs that are from the user's favorite genre. And I guess the question would be, how can we do this? First thing I want to mention is note that storing a song class made this follow-up much more reasonable if we wanted to actually code it. We could just simply add a this.genre property up here into our song class, and then boom, we'd have access to it whenever we're dealing with songs. We don't have to do any sort of extra passing of data or anything like that. Okay, the way we can do that is basically, let's just say we want to have a factor of 2. So any song that's in the favorite genre is twice as likely to show up as any song that is not in the favorite genre. And by the way, this is a magic number, so we'd probably want to store that in a constant. But the easy way we can do this is we just need to, I guess I don't need to hide the solution because it's what I'm going to say anyway. But what we'll do is we'll just store 2 copies of that song in our array. So the probability that we land on it when we do our random index grabbing, like from the math, the probability that we get that number is twice as high. The one thing that's important is when we are saying, all right, a song has been played, we need to remove it. We'd also need to make sure it's not copied. Like if there are 2 copies, we'd have to check I+1 and I-1, see if there is a copy. And if there is a copy, we need to kind of consider that to be played as well. Okay, that covers how we'd approach the follow-up. Oh, there's also one other thing that I did not mention, which is why we are doing the algorithm the way that we are. You might think that if we choose song 4, we can just .shift or like maybe .pop, whatever. Like we can delete this from the array. The problem is anytime you delete an element from an array, unless it's the very last element, it takes O of n time, where n is the number of elements in the array. Because all of the elements after the one you're deleting have to be moved to the left in memory. So that would be inefficient. The way we're doing it now, all we do is we grab a random index, that's O of 1 time, we swap 2 values, that's O of 1 time, and then we increment a pointer, that's O of 1 time. So actually, both of our functions, it's kind of easy to see add song runs in O of 1 time, but play song is also running in O of 1 time. So this is an efficient solution, and that's why we go with it this way. Okay, that's all for this video, and thank you for watching.